Good morning all. So I am Jenisha, working as an assistant professor, Department of Science and Humanities, Nehru Institute of Engineering and Technology. So in this video, we are going to show a demo about a single experiment which is named as estimation of total, temporary and permanent hardness of water sample. So this is what the experiment we are going to see in this video. So before moving into the video, we should know about the applications of the experiment. So whatever experiments we are doing, first we need to know the applications. Then only we have to move towards the experiment. So as I told you, we are going to study about total, permanent and temporary hardness of water sample. So the applications based on this is, it's very important to measure the water quality parameters. So there are different quality parameters of water. For example, we can take turbidity, we can check the pH, we can check the color, we can check the odor, we can check the total dissolved salt. So these are all the parameters should be noted down while for the quality of water treatment. Okay, so in this experiment we are going to find out the amount of hardness present in the water sample. So what are the hardness present in the water sample and how we are going to find out the hardness present in the water sample. So for this I am going to show a small volumetric analysis which is titration. So you can see a burette in my hand. So in this burette there are measurements given from reading 0 to 50. So first you have to fill the burette up to the level. So this is the burette which we are going to use in this experiment. And let me show each and every apparatus first. And this one is the pipette. So I am having a pipette in my hand which is 20 ml. Okay. So in this pipette also we can see a measurement of ring. Measurement is there. Till that we have to pipette out the solution. And the next thing, we are going to use a funnel in this experiment, and this one is a conical flask. So for titrating we are using conical flask, and this is a beaker which I am going to take sample water in this beaker. And other than this we have a porcelain tiles. So the work of this porcelain tile is, whenever we are doing the titration, we need to identify the end point. For that purpose, we are using this porcelain tiles. So let me move into the experiment. For this experiment, I am going to use 4 solutions. First one is EDTA, that is boiled water. So boiled water is your pipette solution. And here comes the standard hard water. So standard hard water is also your pipette solution. And this one is the EDTA. So EDTA is your burette solution. So EDTA, what is EDTA? So EDTA, the abbreviation of EDTA is ethylene diamine tetraacetic acid. Right? So ethylene diamine tetraacetic acid. So now I am going to do 3 titrations. In all the 3 titrations we are going to use EDTA as your burette solution, right? So, and these 2 are the pipette solution. One is boiled water and the other one is standard hard water, and the other one is tape water. So these 3 things we are going to use as a pipette solution. So let me add burette solution first. So using the funnel, I am going to add EDTA as your burette solution. So as I told you, till the mark we have to fill the solution. So no air bubbles should come. If it is a colorless solution, we have to see the upper meniscus. If it is colored solution, we have to see the lower meniscus. So now my burette is filled with EDTA, right? So the next what I am going to do, I am going to keep this EDTA aside and I am going to start my titration 1. So titration 1, we are going to find out the normality, which is EDTA against standard hard water. So this is the titration 1. So for this, what I am going to do is, I am going to pipette out 20 ml of standard hard water to this conical flask. I told you that in pipette we have a measurement, so till that I am going to pipette out. So using your forefinger, we can adjust the pipette solution. So whenever you are pipetting out the solution, don't use your thumb. So when you use your thumb, you can't adjust your pipette solution in a correct manner. So use your forefinger to adjust the pipette. So now I have added standard hard water to the conical flask. Right? So after adding this, I am going to add 2 additional reagents. One is ammonia buffer and the other one is EBT. So EBT is the indicator, which is erythrome black tea. The full form of EBT is erythrome black tea. So I am going to add 5 to 6 drops of EBT to this solution. 1, 2, 3, 4, 5, 6. So I am going to add, I have added 6 drops of EBT. So to this, I am going to add 5 ml of ammonia buffer solution. So ammonia buffer solution, the main reason for adding ammonia buffer solution is to maintain the constant pH throughout the solution. So for that only I am going to add this ammonia buffer to the solution. So when the reaction takes place, this ammonia buffer will not change the pH of the solution. The pH will be maintained in a normal level. So that is why I have added 5 ml of ammonia buffer plus 6 drops of EBT. So now you can get a solution color which is wine red. Okay, so now we have got a color which is wine red. Now I am titrating this wine red solution with EDTA. So when I am going to titrate this with EDTA, so first when you add drop by drop. So the solution should be added in a drop by drop manner. So EDTA, it reacts with the hard water. So already we know that hard water contains calcium and magnesium salt. So why the water is getting hard? It is mainly caused due to calcium and magnesium salts. So we are going to remove the calcium and magnesium salts present in the hard water by titrating it with EDTA. So that is what I am doing. So the water sample contains hardness salt. So I am titrating that with EDTA. So I'll get an endpoint which is steel blue color, right? So the EDTA reacts with the hard water plus EBT and it removes the calcium and magnesium present in the water sample and the color changes from wine red to steel blue. So you can see the changes occurring manually. Within 2-3 drops we will get the end point. So successfully we have received the end point which is steel blue color. So using porcelain tiles you can check the color of the solution, right? So this is the first titration. So first titration I have titrated EDTA with standard hard water. So standard hard water, it removes the calcium and magnesium present in the water sample. So the same thing we have to repeat it for the second time till you get the concordant value. Okay, so for the demo class I have taken only one reading. So whenever you are seeing your reading, you have to take your burette in your hand and you have to note the reading from top to bottom, not from bottom to top. So now I have got reading approximately 23.7. So this is what the titration 1 reading, right? Next experiment we are going to do, as I told you before, we have 3 titrations. Titration 1 is over. So the next one is titration 2. In titration 2 again, I'm using same EDTA as a burette solution, and instead of using a pipette solution, I am going to take tap water. So we are going to analyze the percentage of calcium and magnesium present in the tap water. So for this, I am going to take tap water as the example. Okay, so I am going to pipette out tap water. We are going to find out the percentage of calcium and magnesium in the tap water. So let me discard this solution. Let me wash it with water. Right, now the burette is filled. Again we have to fill the burette to 0 level. Again we have to fill the burette to 0 level. Whenever you are filling your burette, don't forget to keep a funnel, because the solution will not be wasted if you use your funnel. Okay, so I am keeping this EDTA aside. So I have taken till 0 level. Okay. I am going to take 20 ml of tap water. So pipette out 20 ml of tap water. So the same thing, I am using my forefinger to adjust. Okay. So the same procedure we are going to follow, right? So the 2 reagents, that is additional solution, and the other one is EBT. So the same thing I am going to add in this sample also. I am going to add 6 drops of EBT. 1, 2, 3, 4, 5, 6. So 6 drops of EBT is added, and additional reagent ammonia buffer I am going to add in this. 5 ml of ammonia buffer, again it is added in this. So when ammonia buffer is added to EBT, we are receiving a wine red color. So now I am going to titrate this wine red color with your burette solution. So when the titration is carried out, again this EDTA reacts with the tap water, and it forms a complex inside the solution where all the hardness been removed and it is left out with EBT. So we all know EBT is steel blue color. So this is the color of the solution. So after this we have to note down the titration reading. So in first titration we have received the reading approximately till 24. In my second reading, my end point is 14.5. So the reading has been decreased. So this one is the second titration. So using this, again we can find out the hardness. And the last titration we are going to do with boiled water. So we are going to do with boiled water. Again I will fill my burette solution with EDTA up to 0 level. Again we have to fill the solution. Right? Okay. So the next what I am going to do is, I am going to pipette out 20 ml of boiled sample water. So you may ask me a question, why ma'am we are going to take boiled water? Because hardness can be removed by boiling the water. If your water contains calcium and magnesium, When we boil that sort of water, automatically hardness can be removed. So what I am going to do is boiled water. I am going to take 20 ml of boiled water. So again we can see the hardness in a very minimum level. So let's check it out how it is. So I have taken 20 ml of boiled water. Right? So already I told you boiled water means if I am boiling a water, if the water contains calcium and magnesium hardness, it can be removed easily. Right? I am keeping this aside. To the same I am adding ammonia buffer 5 ml. See, ammonia buffer 5 ml and EBT 5 to 6 drops. Right? So we have added ammonia buffer and EBT. I am going to titrate this with EDTA. So I am having EDTA in my burette. I am having boiled water sample in my pipette along with additional reagents, ammonia buffer and EBT. So let's see the titration. So you can get the answer very soon, because here we are using boiled water. So you can get the endpoint as such. So this is the titration 3 endpoint, where you are estimating the amount of permanent hardness in water sample. So far we have seen 3 titrations. One is finding out the percentage of total hardness in your water sample, finding out the percentage of permanent hardness in your water sample, finding out the percentage of temporary hardness in your water sample. So by doing this, so we can calculate the percentage of hardness present in the water sample. So I think everyone has enjoyed this video. Thank you.